Ever puzzled over how nerve conduction velocity tests work? They're a fascinating blend of biology and technology, revealing the mysteries of our nervous system. Today, we're diving into the intricate process of these tests, step by step. Nerve conduction velocity tests, commonly known as NCV tests, are a way to measure the speed of electrical conduction through a nerve. The process begins with the direct stimulation of a motor or sensory nerve. This stimulation sparks an impulse that travels through the nerve. By recording the evoked potential from either the muscle commanded by the motor nerve or the sensory nerve itself, doctors can measure the conduction time. Now, you might wonder, where can these tests be conducted? Well, any peripheral nerve that is superficial enough to be stimulated through the skin at two different points can be tested. This includes a host of motor nerves, such as the ulnar, median, fibular, tibial, radial, femoral, and sciatic nerves. On the sensory side, nerves like the median, ulnar, radial, sural, and superficial fibular nerves are commonly tested. One of the fascinating aspects of motor nerve conduction velocity testing is the recording of potentials directly from a peripheral nerve. However, this means that it is impossible to monitor purely sensory or motor nerves. To isolate the potentials conducted by motor axons of a mixed nerve, the evoked potential is recorded from a distal muscle innervated by the nerve under study. Small surface electrodes typically do this job, recording the evoked potential from the test muscle. Consider a test procedure for motor NCV of the median nerve. The recording electrode is taped over the abductor pollicis brevis, while the stimulating electrode is placed over the median nerve at the wrist. A stimulus artifact is seen at the left of the oscilloscope screen, with a trigger mechanism controlling this and allowing consistent measurements. The stimulus intensity starts out low and gradually increases until the evoked potential is clearly observed. When the stimulating electrode is properly placed over the nerve, all muscles innervated distal to that point will contract. This is a moment where the patient will see and feel the hand jump. The intensity is then increased until the evoked response no longer increases in size. Then, it is increased further to ensure the stimulus is supramaximal. The potentials seen on the screen represent the electrical activity detected by the recording electrode. When the supramaximal stimulus is applied to the median nerve at the wrist, all axons in the nerve will depolarize and start conducting an impulse. This signal is transmitted across the motor end plate, initiating depolarization of the muscle fibers. The amplitude of this potential is a function of the total voltage produced by the contracting motor units. In conclusion, nerve conduction velocity tests are a powerful tool for understanding the health and function of our nerves. They involve stimulation of nerves, recording of evoked potentials, and careful measurement of these potentials. They help us peer into the workings of the nervous system, shedding light on the remarkable electrical activity that governs our physical sensations and movements.